Hello everyone, welcome to our quadratics unit. Today we're looking at 3.3b applications. So we're going to look at some actual questions and kind of apply our quadratics to those and solve some different problems. So the vertex is going to be of big significance in these types of questions. So it says when a largest or smallest value is required, so like a max point or say a min point. So if we're looking for either of those, in any set of circumstances that can be represented by a quadratic function, the vertex of the corresponding graph provides the solution. So basically wherever that vertex is, that max point or that min point, that is going to be our solution. And I got two examples here over on the side. I'm just going to explain those. So if you had something like this first one here on the left, we got on the horizontal axis, the x-axis, we have the number of workers. So this is going to be like 1 worker, 2 worker, 3 worker, and it just keeps going up. And then on the vertical axis, we have the cost. So that could be like $20, $30, and keeps going up. So as you get more workers, right, as you start to pay more people, the cost, it might cost you more for the workers, but overall you're probably going to get the job done a lot sooner, so your overall costs are going to be cheaper. So you're going to pay more workers, you're going to get the job done quicker, and then you're going to reach a certain amount of time where you got the perfect amount of workers and it reduces your costs. Okay, but then you start hiring more workers and basically you got workers standing around, so your costs are going to go back up. You're paying for people that aren't really doing much, so it's not really helping yourself. Okay, so that's where you'd want to try to find, say, a minimum, and that would give you the best number of workers and reduce your cost. Or you could kind of have the opposite, where maybe you're selling an item. So we're looking at this one on the right. You're selling an item and you're thinking about increasing the price. So if you do increase the price, you're going to make more for each one of those items. Okay, so you're going to start to make more money. You got more revenue coming in. But then it gets to a point where you're going to reach the max. So you've increased it as much as you probably should. You're going to make the most amount of money there. If you continue on and you continue to raise the price, you're not going to make as much money because nobody wants to buy something that's really expensive. So if you increase the price to something crazy expensive, your revenue is going to come back down because nobody wants to buy it. Okay, so on each of those graphs there, this is the P and the Q. That's just the vertex. So we're going to want to find the vertex whenever we're looking for the min or the max. Okay, so our function that we were looking at before, f of x is equal to a times x minus p squared plus q. That was just our vertex form. And that's what gave us the vertex, right? That's why it was useful, because the p and the q gave us out the vertex, p and q. Okay, and then it says when x is equal to p, the max or min value is going to be at q. Okay, so that basically says once you get towards p, you're going to be at the min, or you're going to be at the, in this other case, you're going to be at a max. Okay, so both of these is over at p, and then it's going to be q for the max or the min. Okay, next we are into our examples here. So the first one says, two numbers have a difference of 10. What are the numbers if their product is a minimum? So first thing we're going to do, we're going to start out with this first sentence here. We're going to try to come up with some information with that, and then we'll look at the next sentence. So if we have two numbers, okay, and they have a difference of 10, if I had one number was, say, an x, and the other one has a difference of 10, that tells me that it's only 10 off of my first number. So it could be, say, x minus 10. Okay, now you could get different answers for this. You could have used, say, y's, and that would work. Or you could have used x, but rather than saying x minus 10, you could have had x plus 10, because those would still have a difference of 10. Okay, so I got my two numbers. Then I can look at the next statement. What are the numbers if their product is a minimum? So if I'm talking about a product, product means to multiply. So I'm going to take these two numbers, x times x minus 10. Make sure you put brackets around the x minus 10. Okay, and those two things are going to be my function for a product. So this p here, it just stands for product. Okay, so that's my function, and I want to find the minimum two numbers, the two numbers that'll give a minimum product. Okay, so what I would like to find is kind of like on this graph that I had up here. I want to find that minimum point. Okay, and that minimum point occurs at the vertex, so I want to find the vertex. Okay, so I want to take this and I want to convert this into vertex form. And we did that in our last lesson on completing the square. So we're going to complete the square to find the vertex. So first thing I'm going to do, I'm going to distribute the x into the brackets. That's going to give me x squared minus 10x. And then if there was something in front of the x squared, we'd have to factor it out, but there isn't. So I can go into my next step where I take that second term there, negative 10. I'm going to divide that by 2 and then square it. And then that's going to give me my plus and minus numbers that I'm going to use. So that gives me minus 5. Square that. I get 25. So I got p equals x squared minus 10x plus 25 minus 25. Okay, and then if there was that number out in front, what we did was we had to distribute it in to the brackets to the negative number to get that kind of outside the brackets. But in this case, there is no number out there, so we don't got to bother doing that. I can just go to the next part where we factor these three numbers right here. Okay, so I'm just going to put some brackets around those, just might help us a little bit easier if we see them there. Okay, so factoring this is a perfect trinomial square, and the way to factor that, you just take down that sign, so minus, take this number down, but when you do, divide by 2, so it becomes a 5. Got to square those brackets, and then this number comes down, minus 25. Okay, so now this function was the exact same as what I started with, it's just now in vertex form. And because it's in vertex form, now I can figure out what the vertex is. So the vertex is going to be at P and Q. Okay, so this is the P and that is the Q. So it's at negative 5 and negative 25. Okay, and the variables we were using P and we are using X. So this is X, which is one of my numbers. So I already know one of the numbers. This other number here, negative 25, that is the P, that is the product. Okay, so the product is negative 25. That's the minimum product that I can get. The one number, so one number is negative 5. The other number, I'm going to have to use this right here. Okay, it's going to be taking the other number we got, negative 5, and then minus 10. So that's going to give us negative 15. So our two numbers are negative 5 and negative 15. Okay, so again, to get this number, I had to plug it into that first little expression that I had made. Okay, and then if you wanted to make sure that going from this first step here to this step right here was correct, that you completed the square correctly, you can go to your calculator and we'll turn it on and just enter both of these, and as long as you get one graph, you know you did it right. So I'm going to enter in this first one. So there's the first one entered, and then I'm going to enter in this. Okay, and now that I have both of these functions, I can make sure that they're the exact same function by graphing, and I should only get one graph. So it's graphing one of them, there it goes. Still graphing, and it's overlapping the second graph on top of the first graph. And if you'd want to zoom out just to make sure, you go zoom out, click enter. It's graphing the first one, and now it's graphing the second. Okay, and I only get one graph, so this function is the same as this function. Okay, and again, that's just to double check to make sure you didn't make any mistakes. So this next one says a rectangular lot is bound on one side by a river, and then on the other three sides by a total of 80 meters of fencing. So one side has a river, the other side is using a fence. Find the dimensions of the largest possible lot. So let's draw a picture of this first. Okay, so on the one side, we're going to say this is the side with the river. And then on the other three sides, we have, this is our fencing. Okay, and this would be smart to do because this river, it's going to save us some fencing. I'm not going to need to fence the fourth side. Now the total amount of fencing that I have 80 meters of fencing there. Okay, so this side plus this side plus this side is going to have to add up to 80 meters. Okay, now I don't have any names for these sides yet, so I'm just going to call this a length. And this side's the exact same, so those will both be lengths. I can put marks to say they're the same. And then this side I'll call the width. So if I took the L plus the L plus the W, those are going to have to add up to 80 meters of fencing. Okay, so that's 2 L's and 1 W is going to equal 80. Okay, the last part of the sentence, it said find the dimensions of the largest possible lot. So we want the largest possible lot. And if we're talking about the lot, that is referring to the area. Okay, so area I know for a rectangle, because this is what we have as a rectangle, it's just length times width. So the area is equal to length times width, and I have my lengths and my widths just down here. So what I'm going to try to do is replace either the W with something in terms of L or replace the L with something in terms of W. So basically I just want all L's or all W's. Okay, now if I look at the equation that I had down here, I could get W equals with this pretty easy. I just got to subtract 2L from both sides there, and I get W is equal to 80 minus 2L. And now that I know what W is, I can take that and I can put it in where W is. So this is going to give me over here L times, and then W is 80 minus 2L. Okay, and now that I have this function, I want to try to change it into vertex form. So distribute. So I get A equals 80L minus 2L squared. And then I'm going to change the order of this. So I got the negative 2L squared first. Now to complete the square, first thing we want to do is factor out if there's a number in front of the L squared. So I'm going to factor out negative 2. And we factor that out of this term and the second term. Only the first two terms. If there was a third term, I don't do it out of the third term. So that's going to give me minus 40L. Okay, and then what I do, I take that middle term and divide that by 2 and then square it. So that's going to give me negative 20, and then square it, we're going to get 400. Okay, and then I'm going to put that in and I'm going to plus and minus it. So I got negative 2 L squared minus 40L, and then plus the 400 and minus the 400. Okay, and then we got to get rid of that minus 400. To do that, we need to distribute the negative 2 all the way to that. I'm going to move all of this over, so I got some more room to write over here, and I'm just going to kind of compress all of this stuff together. Okay, so I've moved everything over. I'm just going to bring my work up to the top here now. So I got A is equal to negative 2 L squared minus 40L plus 400. Okay, and then distributing that negative 2 to the negative 400, that's going to give me positive 800 over here. I'm just going to slide this stuff over. Okay, so now that we have that, we can finish factoring the inside here. So I got -2, it's going to give me L, take down the negative, take down the 40 and divide by 2, so that's going to give me 20, and that's squared plus 800. Okay, so now we got it in vertex form, so our vertex is at 20 and 800. Okay, so the 800 is the area, and the 20 is the L. So I know the length is equal to 20 meters. And then the width, we still need to find that. But I know the width, we had written that right over here. It was just 80 minus 2L. So the width is going to be 80 minus 2 times L, and L is 20. So that is going to give me 40. So the width is 40 and the length is 20. Okay, so now that we're finished that one, we can move on to our last one, number 3. And this one says, the cost of a ticket to a hockey arena seating 800 people is $3. At this price, every ticket is sold. A survey indicates that if the price is increased, attendance will fall by 100 for every dollar of increase. And that makes sense. If you increase the price, less people are going to come. What ticket price results in the greatest revenue? So we're going to have to find a max, which is at the vertex. And then what is the greatest revenue? Okay, so with questions like this, when you're talking about revenue, I know that revenue is equal to, like if you had some pop cans you were selling and you had 3 of them and each of them were $2, you would just go $2 times 3 cans and you'd get $6 is what you made. This one is a similar idea. We're just going to take the number of items, in this case people, and times it by the price. So let's just write that down. It's the number of items times by the price. Okay, so initially it was 800 people and we times by $3. Okay, but then it said for every dollar of increase, we were going to lose 100 people in attendance. So I'm going to lose 100 people, so I was at 800, and then I'm going to lose 100. I don't know how many 100 people I'm going to lose, so I got to add an n. So n represents how many times I'm losing 100, which depends on how many times I increase the price. Okay, so it was at $3, and then it's going to go up by $1, and that happens n times. Again, could be 1 time, 2 times, 3 times. We don't know, so we got to put an n. Okay, and then once we have this, I'm just filling in R for revenue here. Once we have this, we can do all of our foiling, get all of our products there, and then we're going to simplify and try to get this into vertex form. So we're going to have 800 times 3, that's going to be 2400. Then we got 800 times 1n, that's just 800n. Negative 100n times 3, that's negative 300n. And then negative 100n times 1n, that's negative 100n squared. Okay, so I can put these two terms together, and I'm also going to rewrite the order so that my n squared is first. So I'm going to put negative 100 n squared first. Then I'm going to put my n's, so I have 500 n's now. Again, I'm just collecting these two. And then plus 2400. So now that I have it in standard form, I'm going to start to change it into vertex form by completing the square. So pull out the negative 100 out of the first 2 terms only. You never pull it out of this third 2400. It's only ever out of the first 2. So I pulled it out only out of the first 2, and I'm left with this in brackets. Then I'm going to take this middle number, which was a negative 5. I'm going to divide by 2 and then square. Now, negative 5 over 2 is going to give us a decimal, and when I square that, I'm going to get 6.25. it's okay to have a decimal in this context just because the question we're dealing with is talking about money, and you can have decimals with money. Okay, so when I divide that by 2 and then square it, you get 6.25. So I'm going to add that back in. So now r equals negative 100 n squared minus 5n plus 6.25 and minus 6.25 plus 2400. Then we got to distribute the negative 100 to the negative 6.25. Okay, so everything else stays the same inside there. And then when I do this distribution, that's going to give me positive 625 plus that 2400. Okay, and then just continuing on. To factor this middle part here, we just bring down the n, write our square, sign comes down, that's negative, and then the 5 comes down, but divide by a 2, so we get 2.5. Again, decimals here are fine just because we're going to be dealing with money. And then on the outside, I can add these two terms together, and that's going to give me 3,025. Okay, so from this, we now finally got it in vertex form. I can see my vertex is at 2.5 and 3,025. Okay, and this was the N, and this is the R. So I know my max revenue is going to be 3,025, which was one part of what the question asked for. And then the other part was how much a ticket price is. Okay, now this N, that is not the ticket price. Remember N, when I put it up in here, it was how many times I was going to increase the price by $1. Okay, so our price we wrote was 3 plus N. So let's just write that down here. Price is equal to 3 plus 1 times N. And then our price is then going to become 3 plus 1 times 2.5. And what I get from that is 5.5. So if you had a price of 5.5, really that's saying our price is $5.50. So there's our price. And then our max revenue, we already said what that was. We just got to write it down. So our max revenue, most amount of money we can make, was this number right here, $3,025. Okay, and then if you were ever asked how many people were in attendance, we had our amount, or the number of items, was here. So that's 800 minus 100 times n. So the number of people, if you were asked this, in this case we weren't, but the number of people is 800 minus 100 times n, and n was 2.5. So that's going to be 800 minus 250, and that would give me 550 people. And it didn't ask for that, but that's just in case you guys get one that asks you something like that. Okay, now the n that you guys get, we got 2.5. That is rarely going to be an answer to a question unless it asks how many times are you going to increase or decrease the price. Then that'll be an answer. Otherwise, you always got to plug it back into like the price if it's asking for price, or the number of items, you got to plug it into there. Okay? So I'm just going to write down our homework questions here now. So we're on page 194, and we got a number of questions here. Okay, so there are our textbook questions.